Billy Rinaldi is a senior member of the technical staff with Hortonworks. Interesting fact, Billy was actually my introduction into Accumulo years ago, so hopefully she'll be as insightful here as she was, I know, providing us guidance when we were ramping up on it. So Billy's going to talk to you about tracing, and I'll turn it over to Billy.
Hey everybody, you can hear me okay? Okay, great. I'm going to give an overview of tracing and tell you what's currently going on in Accumulo and HDFS. Feel free to jump in with questions. I've been deep into this for 6 months or so I may miss some basic stuff that I should go over. So basically, tracing is a way to help you understand more about the behavior of your distributed system. If you've ever written a program and got a timestamp before your operation and got a timestamp after your operation and looked at the difference to see how long it took, basically tracing is doing that same thing in a complex distributed system. The way it works is each trace is broken down into a tree of spans, and each span will have a start time and a stop time. The tracing information is passed across RPC, so you're not just getting timing information in your local process, you're getting timing information for what the server is doing as part of the operation you're timing. Let's see, and the basic design comes from a Google paper from 2010 called Dapper. This is an example of what a small tree of spans would look like. When you start the trace, you end up starting at the top level there. The first span has no parents, so it's called the root span. It'll get a trace ID and a span ID assigned to it. And then any spans that are created after that will be children of that span. And the children can also have children. Each span carries around a bunch of information with it. One is a just simple description of the span. So in Accumulo's case, this could be minor compaction, major compaction, or basically any string name describing the operation you're timing. There's also a trace ID. That's a unique ID, and every span in the trace will have the same trace ID. Each span gets a unique span ID, and that's globally unique, not just unique within the trace. Each span also keeps the ID of its parent span, unless it's the root span. And again, there's the start time and stop time for the span, and some annotations that can be arbitrary data that you associate with the span. So they can be key value pairs that are strings or byte arrays. And you can also add annotations at specific timestamps for what's going on at that time within the span. So the tracing system has 4 main aspects that I'm going to go over, just list here, and then I'll go over each in more detail in the talk. The first thing is the instrumentation library. That's what lets you start and stop spans, basically. Now, Accumulo has had tracing for a long time, since it became open source. And its tracing instrumentation library was called CloudTrace and became Accumulo Trace. In the next version of Accumulo that comes out, Accumulo 1.7, we're switching that over to HTrace. The HTrace instrumentation library is extremely similar to Accumulo Trace. They roughly based it on Accumulo Trace. It's not exactly the same, but there's more or less a one-to-one mapping between what we did in Accumulo Trace in the old days and what HTrace does. Let's see. Also HTrace is now an incubator project at Apache. The next thing you need for the trace system is span receivers. So you have your process creating spans, and within the process you'll instantiate a span receiver class, and that span receiver will take the spans you send to it and do something with them. It might store them to the local disk, maybe for testing, or it could send them to a central collector. Span receiver is an interface that HTrace provides, and there are a bunch of different implementations of it that I'll go into more detail about. Let's see. So a lot of span receivers send their spans to some collection system. So the collection system might be a process that's running on a different node, such as the Accumulo tracer, which is one of the Accumulo processes that gets started up when you do a standard Accumulo install. There are typically a small number of tracers for each Accumulo install, maybe just one or a handful, but there won't usually be the number of tracers equal to the number of servers in your system. So it's not like data nodes or T servers. It's more like there are a small number of them. Let's see. So the collection system will receive those spans from all the different processes, and then it will insert them into some central store, such as Accumulo or HBase or Cassandra or LevelDB or whatever. Let's see. And again, examples. An example of a collector other than the Accumulo tracer would be a Zipkin, which is a tracing system used by Twitter. HTrace, the Incubator project, is also working on a new collector called HTrace D that's coming along. I have only tested it out a little bit myself, but it receives traces via REST instead of Thrift, like the Accumulo tracer does. And then, in addition to the collection system, you want a sort of visualization and trace inspection system. Those are sort of paired with the collection system. So for the Accumulo collection system, the Accumulo monitor page provides a sort of simple textual view of traces. In Zipkin, there's a graphical UI that can display the traces, and you can also search for words in the trace description. And in the next version of HTrace, HTrace D will also have a simple UI. So here's a cartoon of what the tracing system looks like. Basically, you'll have your processes that are running instrumented code. Each process will have their own span receiver or set of span receivers, and those span receivers will send spans to some collection system, which will store them. So a little bit more about the instrumentation system. HTrace, I said, was fairly similar to the Accumulo tracing system. I guess HTrace has been around for approximately 3 years or so. Basically, HBase wanted to have tracing like Accumulo did and like described in the Dapper paper. So they didn't want to use Accumulo trace, so they made HTrace, and then HBase has been using HTrace for its tracing. But there's been no HDFS tracing. And then in Hadoop 2.6.0, HDFS started adding a little bit of tracing using the HTrace library. That was a version that was released before HTrace came to the Apache Incubator. Then at the end, around the end of the last year, HTrace entered the incubator and released 3.10 incubating. And Hadoop 2.7 and the upcoming version of Accumulo 1.7 will both use HTrace 3.10 incubating. And the great thing about that is once you have two systems using the same instrumentation system and sending the same kind of spans, then you can get traces across the system. So you can have a single trace that contains your client spans, Accumulo spans, and HDFS spans. So you're getting a lot more data about what's going on in your system. Let's see. The instrumentation library part of HTrace is only changing a little bit. Actually, it's changing slightly more than I would like in HTrace 3.2.0 incubating. But most of the development going on in HTrace now is in developing their own standalone collector system, HTrace-D. It's using LevelDB for storage and using a REST API for receiving the spans. And they're doing a lot of work on this graphical UI. So we'll see how it is after it comes out. It hasn't actually been released yet. I imagine it will be a little time before that collection system is sort of scalable and up to par with other collection systems, such as the Accumulo tracer and the Zipkin collector. So if you want to use tracing, basically the first thing you have to do is load up some span receivers in your process. And importantly, you only want to do this once per process. Like, you don't want to load the same span receivers more than once. We're considering making it so there's deduplication. If you load the Accumulo span receiver multiple times, it would just keep one copy of them. But for now, you need to make sure that you actually only load span receivers once. There are a couple of ways to do that. At the bottom here, the basic way is to do trace add receiver of a span receiver you've instantiated. But it will probably be more convenient to just load the span receivers that Accumulo is already configured to use using this distributed trace enabled tracing call. Or alternatively, load the span receivers Hadoop is configured to use using the span receiver host get instance call. So Accumulo and Hadoop are configured to use tracing separately, but you can configure them to use the same span receiver classes and collection system, which is what you would like to do if you want to do tracing across both of them. So assuming everything is configured correctly, both of these calls should do the same thing effectively. So that just means your process has a span receiver that's ready to receive any spans you create. To actually create spans in your client code or application, you have to issue a trace start span call. You give it the description of the operation you're tracing, and it returns a trace scope object, which is just a wrapper around a span and the parent span of that span. Basically, when you start a span, it becomes the current span as far as HTrace is concerned, and it keeps a copy of the parent span so that it can reset the parent to the current span once the span is stopped. By default, this trace start span operation, it will only actually start a span if a trace is already occurring. So that's what allows Accumulo and HDFS to have all this instrumentation of starting spans, because it won't actually cause any overhead for tracing unless a span has actually been initiated. So to say that you want to initiate a span, you have to add a sampler to the start span method and say, for example, the always sampler. This would say, okay, I definitely want to trace this operation right now, start a trace for me. Once you have the trace scope object, actually you don't even, you could add annotations directly to the span within the trace scope object, or you can just say trace add timeline annotation or trace add key value notation to add additional data to your span. And then at the end, when you're ready to stop the span, always issue trace scope.close. It's very important. The system is not tolerant to you not closing traces properly. So make sure you do that in a finally or something. So the sampling concept is pretty important. So once you start a trace, you're going to get all the spans that you would see within that trace. So you're not going to do sampling on spans within a trace. You get all of the data. So where you want to do the sampling is at the initiator level, so at the root span. You want to sample traces rather than sampling spans within a trace. And the way you do that is by using these different kinds of samplers that HTrace provides. There's a probability sampler that can just sample a percentage of traces. There's a count sampler that will sample 1 in n traces. And you just pass those to the trace start span method. So as far as the existing instrumentation that Accumulo and HDFS have, up through version Accumulo 1.6, Accumulo would trace all of its major and minor compaction operations. In 1.7, currently, it hasn't been released yet, but at the moment I have it set to trace 10% of major compaction and minor compaction operations. This is because we're getting so much more tracing data now that HDFS is instrumented as well. It's more than double the amount of data we had before. So I wanted to cut down a little bit on the tracing done by default, but it's actually configurable. It will be configurable in Accumulo 1.7, so you can control how many of the major compactions and minor compactions you want to trace. We're still tracing 1% of garbage collection cycles, and replication is a new feature in 1.7, and we're tracing 10% of those operations. We aren't tracing any recovery operations at the moment. And in the Accumulo shell, there is a trace command that lets you trace shell commands on demand. Basically, you can issue this trace on command, run some shell operations that you want to trace, and then run trace.off. And then it will print out the spans you just collected. In HDFS, they're not really initiating traces themselves, but they have added a bunch of instrumentation as far as the RPC calls, and in the DFS input stream and DFS output stream, there's a bunch of instrumentation in there now. They do have it set up so that if you configure certain properties, it will initiate tracing in the DFS client if you want. In Accumulo, we don't really want to do that because we already have things set up to initiate the tracing in client processes and server processes. So let's see. So the DFS client tracing is probably not something you would want to enable when you're using Accumulo. So now I'm going to talk a bit about the span receivers that are available. Accumulo's default span receivers is the HTrace client. This is nearly identical to the HTrace client that was available in Accumulo 1.6. It's just been converted to receive HTrace spans rather than Accumulo trace spans. What it does is it looks at a specific zookeeper node to find out where the Accumulo tracer process has registered itself, and then it sends spans to that node. There are a few different configuration properties that you can set for the HTrace client, including its queue size and the minimum size of spans that you want to allow it to collect. Those all have the trace span receiver prefix. To configure Hadoop for the HTrace client, you have a few different properties you have to set. You have to set this Hadoop HTrace span receiver classes property to the HTrace client. You also have to tell it the path where the Accumulo tracer will register itself. You have to tell it the zookeeper host and port pairs, which is something you don't have to provide Accumulo, since Accumulo has a different property where you tell it zookeeper host and port pairs. And in addition, any of the properties that you would have set with the trace span receiver prefix, you need to set with a Hadoop HTrace prefix in the Hadoop configurations. Other possible span receivers are the Zipkin span receiver. This is part of the HTrace Zipkin package. And that one you need to give the Zipkin collector host and collector port. The HTrace REST receiver will be the new one coming out that writes spans to HTrace-D. There's also a Flume span receiver and just a local file span receiver that's mostly used for testing purposes. You can also configure, for example, this trace span receivers and the Hadoop HTrace span receiver classes property to send to more than one span receiver by just providing the class names in a comma-separated list. I'm not totally sure what the production use case would be for that, but it's certainly helpful in testing out different span receivers and making sure you see what you're expecting to see. As far as different trace collection systems, again, we have the Accumulo tracer. This is the one that ZooTrace client span receiver writes to. It registers itself in Zookeeper and then writes the trace data to Accumulo. It indexes, it writes about 3 copies of each span to Accumulo, indexing it in various ways for retrieval by trace ID, span ID, and service, I believe. And there's a sort of very basic textual UI for reading the Accumulo trace table in the Accumulo monitor. The Zipkin collector has this way of writing to it from writing HTrace data to it called the Zipkin span receiver. The Zipkin one is the only one that has pluggable storage. So by default, I think it uses SQLite. I can also write to Cassandra or HBase. There is not an Accumulo storage for Zipkin yet, unfortunately, but hopefully someone will write that at some point. And Zipkin has a bit of a fancier UI. It allows you to search for traces instead of just retrieving them by ID, and there's sort of a graphical display. And I'll show you a few screenshots of these in a minute. And then the HTrace-D trace collector goes with this HTrace-D REST receiver using LevelDB for storage and also providing a search and graphical UI. So I'm not sure how well you guys can see this in the back, but this is an example of what a trace looks like in the Accumulo monitor page. You get to it by clicking the recent traces link in the left-hand column. If you can see 2 columns of numbers there, it's not explained very well. The first column is the amount of time that span took, so stop time minus start time. And then the second column is the offset of the start time as an offset from the start of the root span. So how far along in the process did it came along. So to collect the span, what I did is I issued trace on in the Accumulo shell. I ran a create table command. I inserted 1 entry, and then I flushed the table, which initiates a minor compaction in Accumulo, and then I issued trace off. So that generated quite a few spans. All the ones you can see on this page are associated with the create table operation. You might or might not be able to see in the middle there is one name node span that's been collected that is issuing a make directory for the table. Scrolling down a bit, we get into where it is issuing the insert command. There's a pop-up box here showing key value pairs that are associated with this minor compaction span, showing the key extent, number of entries in the minor compaction, and the size. So, I mean, it's nice to have something baked into the Accumulo monitor to show the traces, but again, it's very basic and it's only textual. So this is what the same trace looked like in the Zipkin UI. I set it up so that I was using both the ZooTrace client and the Zipkin span receiver at the same time, so it's the exact same trace getting written to them. So it's a little bit easier to tell the elapsed time on these. Everything in the top portion is the create table operation, and then sort of the column in the middle is doing the insert. And there's some good summary information at the top too. It shows you the total number of spans in the trace and the number of services involved in the trace. In this case, it's the shell, the T server, the master, the name node, and the data node. And you can highlight different services, probably one of the most useful differences here is you can collapse different sections of the trace. So here, everything is collapsed except the name node operations. So this kind of highlights that there's that name node makers we saw in the table create, and then there's also a name node operation happening in the flush operation. If we just select data node operations, we see the only time we got a data node span was in the flush. The insert and the create table didn't touch the data node at all. Even with just these basic trace analyses, and I mean, it's only happening on one node, you can see how it sort of breaks down your trace operations into different parts that are happening on with different components on different servers, and gives you a much better way to analyze that than, say, just digging through tablet server and data node logs. So you can imagine that it would be even more valuable if you could figure out that this of one of your many hundreds of data nodes is the one where the operation is taking the longest. So in summary, as of the next version of Accumulo, with the proper configuration, we'll be getting a lot more detailed trace information coming from both HDFS and Accumulo due to the use of the common HTrace library. You do have to make sure to configure them in a compatible way so that they are both sending their trace data to the same place. And you have at least a couple different options for visualization of this trace data, and hopefully more in the future. Thanks. Any questions? The question is, how does, say, the server know which operations are associated with a particular client trace? And it's because the trace data is transferred with the RPC calls. So the client will initiate RPC calls, and that RPC will have the ID of the current trace and presumably the parent span as well. So that gets copied over, and then only stuff associated with that particular RPC call will then, yeah, exactly. So if there's, so that's how it separates it by RPC, and then if there's no tracing going on, then it just doesn't. Or in Accumulo's case, it still initiates some of them for minor compactions and major compactions. Yarn is not tracing itself, but Yarn wouldn't be an obstacle. So if you were running Accumulo on Yarn, Accumulo could still trace itself. Let's see. Yeah, I don't think I've heard. So, and again, if you were, say, running MapReduce on Accumulo, you would still get the tracing from Accumulo. But let's see. I would have to look and see if anybody has opened tickets for adding instrumentation to Yarn. I guess you'd have to be. I could see doing it in MapReduce, maybe. So in Yarn, you're sort of just starting a container and then letting it run for a while and letting it stop. If it's like a long-running container, you probably wouldn't want to be doing tracing in Yarn there, because you could potentially be, tracing the life of a tablet server, for example, which is not something you would want to do. So maybe it would be more appropriate in the application level rather than in the resource management framework. Yeah, they actually talk about that in the Dapper paper, and specifically they want it to be on all the time. You definitely want to sample it down so the amount of trace data being collected is appropriate, but you do want some percentage of even production applications being traced. You just control that sampling. If you're really collecting a lot of data, it's possible it could have an effect on the specific operation being traced. But if you only do 1 in 1,000 of them, then it's not too bad. Let's see. It's handled pretty well. There is a trace runnable object that wraps a normal runnable, and then it, traces the things that happen within that runnable. It's a little bit tricky. I had a hard time debugging an issue with the trace runnable. Basically, actually it was specifically related to using thread pools. Basically, at one point we were tracing the entire life of like a reused thread in a thread pool, and that's not something you want to do. But it is possible to do correctly. It's just a little bit tricky. I feel like for the most part, you would use it intentionally to analyze the behavior of your application. It's not necessarily something you would do all the time, but maybe before you deploy it, you would check out its behavior and see if there's anything you can optimize. Or maybe you see a problem going on and try to figure out where that is. But it's probably not data you're going to find yourself looking at all the time, but when you need it, it might be really useful to have. Yeah. Let's see. So I don't know that much about other span receiver implementations, but the Accumulo ZooTrace client is asynchronous, and basically if so sending spans to the span receiver in process won't be a problem, and basically if it gets too full, it'll just start dropping spans. So again, since it isn't essential data, if there are outages in the tracer or whatever, it can just drop the data. Great, thanks.